What's up guys, it's Sean Victor and welcome to your 7th Autodesk Fusion 360 tutorial. In this tutorial we're going to cover how to create an enclosure for any sort of PCB that you've brought in from Eagle. So you can see from this design I have here, this is just an example of what we're going to create today, but effectively if I get rid of the enclosure, you can see that initially we start out with this board and we've already gone ahead and added all of these different components on top of it, and now we have a pretty good 3D model representation of what our PCB looks like. But now it's time to actually design a casing or enclosure for this whole thing. So you'll see that when you create an enclosure, you want to be able to still have access to a lot of these ports. So you can see that we have access to the micro USB port for our ESP32. And you can see I have a little JST connector for the LiPo battery that I may need to power this thing with later. And here's access to like the coin cell battery there. But really, it really will depend on your own application and what you want to have access to. And that's kind of the whole point of designing your enclosure in this way. Okay, so let's go ahead and get started. I'm going to go ahead and start with the board itself. So let's say this is the board that we created and now it's time to make the enclosure. The first thing that I like to do is to create an outline of this board. Okay, the outline will effectively be used to come up with the initial enclosure design. It gives us a bit of a rough estimate, and you'll see if that doesn't make sense right now, you'll see it will. So I'm just going to go ahead and create a sketch on this top side of this PCB. And I'm going to go ahead and use the project tool. And the parts that I want to project are this whole PCB itself and any sort of features that I may want to capture later. Okay, so I'm just actually going to get the PCB for now and we'll handle all of these connectors later. Okay, just going to hit finish sketch, and you'll see that it kind of disappeared. And if we go under sketches, it should be the last sketch we created. You can see if you click on it, it highlights everything. What we're going to do is we're going to right click on the sketch. We're going to hit save as DXF. By saving it as a DXF, we can move this sketch over from one design to the next design. So I'm just going to call this sketch 1. Okay. Now I'm going to go ahead and actually create a new design, and in this design we are actually going to create the enclosure itself. So I'm going to start by creating a new sketch. I'm just going to start with this bottom plane, and I'm going to go ahead and hit insert and then insert DXF. I'm going to select the DXF file that we had before, which is the sketch 1. And you'll see that the whole thing gets brought in. I'm going to go ahead and hit OK on the insert DXF, and this is what I should have left. Now a lot of what you have right now is not really what we need. You can see like all of the vias, for example, got imported into our design, but we really don't have any use for the vias. So I'm just going to go ahead and drag, select, and delete all of these vias. Okay, and hit the delete button, and that gets rid of those. And I also don't need these pin headers, so I'm going to do the same thing, delete those. Pin headers here, delete those. Okay, so I'm pretty much left with everything that I need. Now instead of having this little divot right here, I'm just going to use a line tool and complete it just like that. That's just per choice. You don't have to do this, and in most designs you probably won't have something like that. But I'm just going to do that and get rid of the divot. Okay, so this is a pretty good outline of what the board will look like. The next step is actually going to be creating the outline shape. So what we're going to do is we're going to create this lip. So you can see the casing itself has a lip to it and it has a base. Okay, you can see that the base at the bottom makes up a certain amount of thickness, and then there's also a lip around the whole board itself. Okay, so this is something that we're probably going to have to 3D print, and this will hold the PCB assembly. Okay, let's start by creating that lip. So to create the lip, you're going to go under the modify section, and we're going to select offset. Okay, now the first part of the lip that we need to create will be a tiny amount of offset. Okay, generally you can make this about negative 0.1, and this is purely so that when this purely is there to compensate for the fact that 3D printers have a bit of a tolerance factor to them. Okay, so this is going to make it so that the 3D printer has a bit of a margin of error, and our actual PCB will be able to fit in there. Okay, the second line we're going to create is another offset from the tolerance line, and the amount we're going to do, okay, so it's not letting me do it on the tolerance line, but if I hit offset on the original line and then I go out, we can actually use this to set our value. In our case, I'm going to do 1.1, so that the thickness around this whole border is going to be 1 millimeter, and I'm going to hit OK. Okay, so now we have this lip. So the first thing we're going to do is we're going to start by creating the base. All right, to create the base, we're going to hit Finish Sketch, and I'm going to just change the orientation just a tad bit, and I'm going to hit the Extrude button, and I'm going to select everything. Okay, because this is just the base. Okay, the base is supposed to be flat, there's no holes in it, and I'm going to extrude this downward. Okay, it's kind of important that you extrude this downward and not upward, because you'll see that the sketch will kind of disappear, but I can extrude upwards after I've done this downwards extrusion. So I'm going to extrude this downward, hit OK. Okay, so I've done that, and the sketch went ahead and disappeared. Now we still want to be able to use that sketch, so I'm going to go under the sketch section here and then toggle the visibility so it turns back on. Okay, so the next thing we're going to do is we're going to extrude this outer lip up by a certain amount. Okay, we don't know what this amount is initially, so I'm just going to say like 8 millimeters. You can set it to whatever. This is really just there so that we can get an idea of, you know, how high it actually needs to be. Now the process of figuring out how high it needs to be will come from us trying to create an assembly real quick, but before we do that, instead of just placing the board into this enclosure directly, we're going to make it so that there are some little spacers on each of these holes. Okay, this will give a little height offset to the board. Okay, you'll see the importance of that very soon. So I'm just going to go back to the sketch, hit edit sketch, and I'm just going to make a small outer lip around there. I'm going to make that about 3.5 millimeters, and of course you can set this to really whatever diameter you want. 3.5, and hit finish sketch. Okay, so now that I've done that, I'm going to go ahead and do another extrusion on each one of these holes. And this is just going to act as these little standoffs. Okay, I'm going to hit OK. And you can see that the sketch is still showing, and I'm just going to toggle the visibility of it just so it doesn't get annoying. And I'm just going to hit save. Ask me what I want. I'm going to call this Enclosure 2. Okay, so I have this enclosure here. Now, in order for me to create an assembly, I'm first going to have to create a new design. I'm going to hit save and I'm going to type in assembly. Okay, so I have this assembly and now I can start dragging stuff in. I'm going to drag the enclosure in first and I'm going to hit OK. Now it's important that we ground this enclosure. So I'm going to right click on it and hit ground. Okay, this is going to prevent us from accidentally moving this when we try to add other components in. So I'm going to go ahead and now move the ESP little sensor shield that I've made in here. I'm going to rotate it into its proper orientation. Okay, that looks about good. Now what I'm going to do is take one of these and I'm just going to create a simple joint. Okay, in this simple joint I'm going to place it in one of the holes, and you can see that when I do that it's kind of going outside of the enclosure. So I'm going to get a top-down view and then rotate this into place. And you can see the whole purpose of doing that offset that we initially did on the lip, you can see that there is a small amount of tolerance between the edge of the board and the inner edge of the enclosure we've made. So that gives us a bit of spacing. Okay, and I'm going to go ahead and hit OK. Okay, so it looks good so far. And you can see that our board fits, but it, like we said before, it is a bit shallow. Now, one thing to take note of is that there is something sticking out right here. So this is the whole point of having those little standoffs we created before. Currently, the standoffs are not tall enough right now. Okay, so a piece of the PCB is actually sticking out. To get a better view of this, we can use the inspect tool and then click on section analysis. If we click on this and then we click on the face that we want to start the section analysis on, I'm just going to select this face. As I drag it back, you can see what the cross-sectional view looks like. So you can see that this little JST connector is currently inside of the enclosure. So to fix this, we need to figure out what the distance, how much we need to increase the height of this standoff. In our case, I'm going to use the inspect tool. I'm going to click from the bottom of here, and I'm going to click to the location that I need it to be. So I'm going to click on this little surface here, and it's telling me that the distance I need to move it up is 2.8 millimeters. Okay, so I'm going to go back to the enclosure now, and go back to the extrusion we did before, and I'm just going to add 2.8 millimeters, just like that. And then I'm going to hit save. And this is what's really nice about Fusion, is that I can simply just hit get all latest, and you can see it automatically updates it. And now there is no part of this JST connector that is inside of the enclosure anymore. So now we're good. Okay, and that solves our first issue. The next issue is that this is simply not tall enough for the whole board. So if you ever want to get out of the section analysis, you can simply just hit the analysis button, the toggle view here, and you can get in and out of the analysis just like that. Okay, so the next thing is to figure out how much of a height increase we need to add to this lip. So I'm going to do that by hitting the inspect tool and then clicking on the tallest part of our object. And you can see that I need to add about 15.82. I'm just going to go ahead and round that to 16. So I'm going to go back to this lip here, and I'm just going to add 16 to it. Just like that. Okay, we added a pretty considerable amount of height to it. I'm going to hit OK and save. Now if I go back to this assembly and hit get all latest, you can see, okay, now we have a good amount of height to this board. So now we're covering pretty much everything we need to. At this point, what's really left is to start creating the cutouts for each of the connectors that we want to still have access to. Let's start with the JST connector that's on this side. So currently we can't see it. So what will actually help us is to use that section analysis we had before. So I'm going to quickly turn that on again. And now we just need to figure out where it is located. So what I'm going to do is off on a piece of paper right now. I'm just going to take note of some lengths. Okay. Particularly, I'm going to take the length from this side of the enclosure all the way to the end of this connector. And for that value, I'm getting 7.945. Okay. And the next thing to take note of is that the height, if y'all remember, and we can actually go ahead and get the actual value of it. If I hit the inspect and I click on this bottom line and I click on this line, you can see that it is the base thickness is 2 millimeters. Okay, so now that I have that, I need to figure out how wide this connector is. So I'm going to hit inspect again. I'm going to click to find the width, and it's telling me the width of this connector is 7.9 millimeters. And now I need to figure out the height. So to find the height, I'm just going to hit the inspect tool again, click from this bottom face all the way to this top. Let's try that again. Inspect from this face all the way to this face, and I'm getting 6.37 millimeters. Okay, so now if I go back to the enclosure, we can go ahead and take note of these. I'm going to go ahead and create a sketch on that face, and you'll see that as I try to lock onto like a corner per se, it's not letting me, so I need to use the project tool and just go ahead and quickly project on here, and now I can actually have access to locking onto these corners. So I'm going to double click on that sketch I just projected with, and I'm going to use these little dimensions that I took before. So I need to go out by 7.945, and then I need to go up by 2 millimeters, and then I need to create a rectangle, and this is going to be for the cutout. The height of this needs to be 6.37, and then the width of this needs to be 7.9 millimeters. Okay, so now that I have that, I'm going to go ahead and hit save. Actually, before I hit save, I need to do the extrusion, so I'm going to finish the sketch. I'm going to hit extrude. I'm going to click on the face that I want, and instead of hitting distance, I'm going to hit to object, and I'm going to rotate this around, and I'm going to click on the back side of the hole. Alright, so once I do that, you can see that there has been a little bit of a cutout made, and I'm going to hit save, hit OK. If I go back to the assembly now, I'm going to turn off my section analysis, and I'm going to get all latest. And you can see now that we have a bit of a opening here. Now you can see that my opening is a bit taller than it needed to be, so we're going to quickly fix that. So if I go from here to here, you can see that I'm off by about 1.57. I'm going to quickly fix that. Edit the sketch. Okay, so by doing that, I'm going to hit save, try that again, and let's update this, and that looks much better. Okay, so now I have access to that connector. Let's go ahead and do that for this coin cell and then the micro USB connector. So Next things next. So I'm going to use the inspect tool and I'm going to hit section analysis, but instead I'm going to click on this face here. And one thing that is a bit of an issue at the moment is you can see that this pink section is specifying that there is material here, but there's also a point of intersection with our enclosure and where the micro USB is right now. Okay, so this is a bit of a problem right now. This means that we wouldn't actually normally be able to insert this board into our enclosure without there not being enough room. So to fix this, what we can do is we need to, so if I zoom in here to get a better idea of what I'm talking about, this micro USB down here is currently inside of the enclosure. So to fix this, I'm going to go back to the enclosure and I'm just going to edit our first sketch. And the amount of offset I've given is not enough. So I'm just going to make this a bit bigger. I'm going to make the overall width bigger as well. Compensate for that. Finish sketch. And I'm going to hit save. And now if I go back to the assembly and we get all latest, you can see now there is enough clearance for this micro USB. And now we don't have that same problem. Okay, so that I have that, just going to do the same thing I did before. We're going to go look at the section analysis again, click on this face. I can't actually, so I have analysis turned off, which is why I couldn't see that before. But if I try this again, now we can kind of see. And I'm just gonna keep changing this until so about 1.2 is when I can finally get through this material and see the connector. Okay, so now I need to figure out where this connector is in relation to, you know, the bottom faces, just like we did before. Okay, so I'm going to click on the side face and then I'm going to click on this edge here. And we can see, I'm going to take note of this, is that we are 9.13 millimeters out that way. And then we're going to go close. And we're going to go from this bottom face to this lip. We are up by 2.03 millimeters. And now we need to figure out what the width and height of the connector are. So going from here to here, I'm getting 8 millimeters wide. Okay. And then the next value is going from this top to the bottom. We get 3 millimeters in height. Okay, so that's all the information we need for that connector. And while we're at it, we might as well get the data for this connector here as well. So I'm just gonna go ahead and get my distance from this side here. Take note of that, which is 5.715 millimeters. And then the distance from here all the way to here is 19.07 millimeters. And now we need to get the width of the connector itself. So we're going to go from here to here, which for us is 13.53, and then one more dimension is from here to here, and that's 2.437 millimeters. Okay, so I should have everything now. I'm going to go back to my enclosure, and I'm going to create a sketch on this face. And just like I said before, we're going to have to do a projection. Yeah, we're going to hit OK. All right, now we're going to actually write down the measurements we got before. So I need to go 4.03 up here, and then I need to go out by 9.13 millimeters, and then the rectangle size of this connector is 3 millimeters by 8 millimeters. Great. And then from here to here, I need to go up by 19.07 plus 2, because that's the height of the base. And I need to go out by 5.715. Okay. And then the width of this connector is 13.53. And then the height of it is 2.437. Okay, so now that I have that, I'm going to do an extrusion. Instead of distance, I'm going to say to object, and it cuts that out for me. And I'm going to hit save to view it in the assembly. And I'm going to turn off section analysis, get all latest. And now you can see that we have access to both of these ports. And that is pretty much it for the connectors. The last thing to do, the very last thing to do, is to create the lid for this. And so to create the lid, we're going to create a sketch on this, and we're going to create it on the lip itself. And we're going to do a project. And I'm going to start with the lip itself. And then I'm also going to capture these holes, because these holes are going to be what we're going to screw into. And it's going to screw the lid onto all of this. Okay. I'm going to hit OK. Now I hit Finish Sketch. And I'm going to find the latest sketch, which is this. And I'm going to hit Save as DXF. And we're going to call this Sketch 2. Alright, so now I need to create a new design for our lid. Going to create a sketch. Then I'm going to hit Insert DXF. Find that DXF file from before. Now we have our lid. Okay, so the one thing I'm going to change about this is that in order for these two 3D printed parts to mesh with each other, I need to create a small tolerance to this part. And the way I'm going to do that is I'm going to right click on the sketch, hit edit, and I'm going to make this a little bit smaller than what it currently is. And in fact, I'm just going to say 0.1 is a very good amount for a 3D printer to be off by. Okay, so now that I have that, we are first going to start by creating the base of our part. So I'm going to select everything except the holes, and we're just going to extrude that down, or up in our case. We extrude it by -2 millimeters, and you'll see that the sketch disappears. So I'm going to turn it back on, and instead of selecting this outer lip, we need to do this inner lip, and then we're going to extrude this down by another 2 millimeters, which is fine. And I'm going to hit save. We're going to call this lid, and I'm going to turn off the sketch, hit save again. All right, so now that I have a lid, I'm going to go ahead and turn off a lot of this. Alright, so now I should be able to drag my lid in. And I'm going to rotate it in its proper orientation. I'm going to create a quick joint. Let's see. Just like that. It's looking good. And then I need to move it down by 2 millimeters. Just like that. Okay, so the very last thing to do is do a quick inspect, and that will be by using our first section analysis. And there is one issue with this, and that is that the lid is currently smushing this component right here. So there's kind of two ways we can do this. Either we can make this taller, or we can make the lid a bit thinner. And let's try doing that first. So I'm going to make the lid only 1 millimeter, and we'll try that. We'll hit save. We'll look back at this assembly, and we're trying to see that this doesn't intersect. We're going to try getting all the latest. Okay, so that didn't quite help. So I'm just going to go ahead and make the height of our enclosure a little taller. So I'm just going to do a quick extrude on this. Do about 2 millimeters. We'll see if that works. And I need to actually save that. And then let's look at this assembly again. We'll go ahead and update our components. Alright, so we got currently our joint here. I'm going to delete the joint, and we're going to try redoing this. So I'm going to rejoin this. Just like that. Okay, so now we've got a lot of space. And perfect. Okay, so there's no intersections. You can see that the highest point of our board is not making contact with the top of the lid. We can go ahead and turn off our section analysis, and bam, we have an enclosure. Okay, so this is pretty much it. I'm just going to turn off this sketch here so it doesn't show up in the final assembly. I'm going to update that. Try that again. All right, so now it's gone, and bam, we have an enclosure for our design. Okay, so that's the process of creating an enclosure. It may not be the exact same for your board, but the process is effectively the same. Okay, and that's all I have for you, so I will see you in the next tutorial. All right, see ya.